In this video, we will build a spreadsheet simulation model for a single server queuing system. The modeling approach that we're going to use is taken from an earlier model that I built for an emergency department patient flow simulation using spreadsheets. In that model, we had a more complicated system with multiple servers and other aspects of the queuing system that we won't be modeling here. However, the basic approach is the same. What we're doing is we're using rows to simulate each minute in time. So if we take a look at the spreadsheet template that I have here, what we have is it organized in three sections. We have the input on the left at the top. We have the output on the right at the top, and then we have the actual simulation model underneath, starting at row 8 with the formulas beginning at row 9. And what we're going to go through in this video are the formulas that we're going to create for the input and then also for the model beginning in row 9 and row 10, and then copying the formulas down as appropriate and then the output as well. So this particular single server queuing system is just like an MM1 system. We have Poisson arrivals, so the number of arrivals follow a Poisson distribution, and the service time follows an exponential distribution. So to begin, let's start with the arrival rate. We're going to use the same numbers that we used in class. So we had a 10 customers per hour was the arrival rate that we saw in the example in class, and then we had an average service time of 5 minutes exponentially distributed. Now to determine the service rate, remember how we do that. I'll just go ahead and repeat. I'm going to create a text box here. So we'll have the service rate, and what we're going to have in this particular situation is we're going to serve one customer for every 5 minutes on average. And then if we multiply that by 60 minutes per hour, we'll get our service rate in customers per hour, which of course will be 12 customers per hour. Now if we set up the Excel formula for this, it's just going to be equal to 1 divided by the service time, which is in cell C3. Let's put black brackets around this so that we multiply 1 over C3, and that's going to be multiplied by 60. And then of course we'll get the 12 customers per hour for our service rate. Now that we have our input, let's begin with the model. Let's start the first at minute 0, at time 0. The first formula that we will be creating is just a simple random number formula, and so of course we will use the rand function for this. That will give us a random number between 0 and 1. For the entire simulation, we can just copy that formula down. Now right now we're seeing the same value. That's because I have set up the cell calculation to manual, so the cells are not being updated. If I want to have it update automatically, I could use the automatic feature, but with simulation it's often helpful to use the manual setting, and then we control when we want the simulation to be recalculated. So we can just recalculate the cells anytime, and then we're getting a variety of random numbers between 0 and 1. Now to determine if there's an arrival or not, what we will do is use the following formula. So this is going to be equal to, what we're going to do is use an if formula. We're going to compare the random number which we got in cell C9, and we're going to compare, is that less than the arrival rate that we have in cell C2. We're going to put an absolute reference on C2 so that when we copy the formula down, it's always going to use C2. However, what we need to do here, because that's the arrival rate per hour and we're looking at it every minute, is we should get the arrival rate per minute, so we'll divide by 60 here. Now if C9, the random number, is in fact less than that, then what we will do is we will then say that we do have an arrival, and that will denote as a 1 for when there is an arrival. Otherwise, we'll have 0, which will be the case when there isn't an arrival. So we're going to simulate random arrivals here, which is appropriate for the Poisson distribution. And so that's what we're having for each row in time. Okay, so here we have our formula to simulate whether or not we have an arrival at each minute in time. And that formula we can copy down as well. And if we recalculate, sometimes we will have an arrival and sometimes we will not. Okay, the number in Q formula is a more challenging formula. However, for time 0, if we're starting with an empty system, it is simply 0 at the beginning. The formula that we will have in cell E2 will be different. We're going to leave it and we're going to come back to that later. It is a more complicated formula. So next what we're going to do is look at the formulas for the server. So we have determined the random number for the arrival, and then we've done the arrival formula, and we know that there's no customers in the queue at time 0. Now we're going to set up the first formula for the time 0 to determine whether or not the server is busy. After that, we'll look at determining the amount of time that the server will have left, the number of minutes that will be left serving that customer, which again will be based on an exponential distribution. And finally, we'll determine whether or not a customer exits the system at this particular row in time. Okay, to determine whether or not the server is busy, well, at the very first row for time 0, this is just a matter of whether or not we have an arrival. So we can just use an if statement. If we have D9 equal to 1, then the server will serve that customer right away, and we'll have a 1. That means the server will be busy. Otherwise, the server will not be busy, and we'll have 0. Now, it's more complicated for the case when we have a general time t, so beginning at time minute number 1. Now what we're going to have is not just the case of potentially the server being busy because of an arrival. There are actually 3 different cases where a server is busy at time t. The first possibility is that there might be a customer that is being served from the previous minute, and that customer is still being served. So if the server is still serving a customer from time t minus 1 in this particular minute, that means that the time left at time t minus 1 must be greater than 1. So that's one possibility. Another possibility is that there's a new customer that we're going to now serve from the queue. So in that case, the number in queue would need to be greater than 0. So service would finish from the previous customer would just be finishing, and then right away would serve a new customer in this particular minute from the queue. That's a possibility. And then the other possibility is that there's no customer being served in the last minute, or the customer's finished service in the last minute. There's nobody in the queue, but it's possible that a new customer has just arrived at this particular time t. So those are the 3 possibilities. So let's construct a formula to deal with these 3 possibilities, and we're going to use an if statement together with an or statement to deal with those 3 different cases. The first case that we talked about was if the time left, now we haven't done the time left formula yet. However, once we do, that will get populated accordingly. So if the time left is greater than 1, and that's 1 minute, that's going to be, the server's certainly going to be busy. If that's because it's still serving the previous customer from the previous minute. Another possibility is that the number in queue is greater than 0, and then that would be the case where the server is just finishing serving the previous customer in the previous minute, and then it's going to start a new customer from the queue. And then the other possibility is that there's no queue, but there's a new arrival, and then we're going to be busy, the server is going to be busy serving that customer. If any of those cases are true, then the value of the server being busy is going to be 1, and otherwise the server will not be busy if any of those three cases do not hold. So at that point, we would be able to copy down the busy formula and recalculate cells. Okay, next let's work on the time left formula. Now this is again going to be determined based on the exponential distribution. So we're going to use the formula that we had learned for an exponential service time to draw an observation from an exponential distribution. In this case, that's that formula we have with a random number, but then the rand function. But then also we're going to consider the other aspects of the formula as well. So let's go through this first. So this is another case where the formula at time 0 is going to be different than the formula at time 1. So let's start with the formula at time 0. First, we're going to determine if there is an arrival and then the server is then busy, then that's going to be 1. If that's the case, then we're going to definitely want to determine a random service time for this new customer. Otherwise, the time is just going to be 0 because the server will not be busy. In this case, we want to make sure that the time is going to be at least 1. So I'm going to use a max function of between 1, and it's going to be max of 1, and then whatever we get from the random service time. So that way, with the random service time from an exponential distribution, and then that way we'll get at least 1 minute of service time. So now what we're going to do is we're going to have that formula in a moment, but we're going to round it as well as we saw in class, to make sure that we get 0 decimals, so we get a number of minutes as an integer value, and that's because the exponential distribution is a continuous distribution, and it is possible to get fractions from the exponential distribution. So now, again, as we saw in class, we're going to have minus, and then it's going to be the average service time, which is in C3, and we do want the dollar signs there to make sure that it's an absolute reference, so when we copy the formula down, we always use the same average service time reference. And then we're going to do is we're going to multiply that by ln of 1 minus rand. Now note that this rand formula is going to generate a different random number than the random number that we have in column C, and that's appropriate. We should not use the random number that we have in column C because that's a random number associated with the arrival process. If we, in this case, have the exponential distribution for the service process, this is a different part of our system, so we want a separate random number, one for the arrivals and one for the service. So you could put the rand function in another column and perhaps call it random number 2. Or you can put it right embedded within the formula here as we have it. Okay, so now what we'll do is we'll close up the brackets as appropriate. Here, what we're going to do is close up the part of this, but then we want to do is round to 0 digits. So we're going to put the 0 here. Okay, and then that's going to close out the max function. And then what we still need to do is, in the case that F9 is not equal to 1, that's that the server is not busy, then the time left that we want to be is going to be 0. And then after this, we just need to close the bracket. Okay, that completes our formula for the time left for at minute 0. The time left formula at minute 10 is not the same, but it is quite similar. We do have the same max 1 round minus C3 times ln 1 minus rand, and the appropriate zeros that follow in brackets that follow. We're going to have that because we're going to be generating a random time left from an exponential distribution at times, but it's a little bit more complicated in terms of a few more cases that we're going to have to consider, or at least one more case. So let's enter this, and then now let's work on the next formula. So the thing that we need to consider now is if the server is in fact still busy, then what we need to do is, rather than issue a new service time, we would just be decrementing. So reducing the service time, the time left, not time left by 1. So each row represents a minute. So every time we go to the next row, if in fact the time left is greater than 1, then we're still going to have more time to be served for that particular customer. So then it's just a simple matter of reducing the time left by 1 or decrementing time left by 1. Otherwise, what we do is check to see if the server is busy, for another reason, and in that case, it would be for a new customer, and then we would need to generate a new service time using the same max 1 round minus C3 times ln 1 minus rand, and so on. So let's put in this formula now. So what we need for this case is we're going to have if G9, which is the time left from the previous minute, if that's greater than 1, then all we need to do, as I mentioned, is to decrement. So we'll just subtract 1 from G9. Otherwise, what we need to do is have another case where we're going to check to see is F10, in this case, is the server busy, equal to 1. If that's the case, then that means that we're serving a new customer, and we need to establish a new service time from the exponential distribution. So we'll use the same part that we had in the previous row for G9, and we're going to do max of 1, and then we're going to round the service time. It's going to be C3 minus C3, $C, $3, times ln of 1 minus rand and then we'll be rounding to 0 decimals. Oh, I need one more bracket first. And then another bracket. And then otherwise we have 0. Okay, and that concludes our time left formula for row 10. And that's the one that we're going to be able to copy down. And then the final formula in the model that we need to create in row 9 is the exit formula. And this is just simply determining if in fact the time left is 1. Anytime that happens, we know that a customer is leaving the system. So we just do is G9 equal to 1. If it is, it means somebody's leaving in this particular minute. We're going to have a customer exit, otherwise there's no exit on that minute. And that formula is going to be the same for all minutes, so we can just copy that one down and recalculate. Okay, so there we see somebody being served at the very beginning with the time left of 15 minutes, and it's decrementing down. Okay, the final formula that we have to come back and complete is the number in Q at minute 1 or at time t and beyond. So every time minute. So we started with 0, but now let's think about the different cases that we're going to have for the number in Q. The first thing we're curious about is the server busy at the previous minute at time t minus 1? If the server is busy at time t minus 1, well then that means that the number in Q is going to be however many we had in the queue at time t minus 1, plus if there's an arrival. We'll have to add that as well. So arrival can be 1 or 0. And then the next question is, did a customer exit the system at the time t minus 1? If that's the case, then we want to consider the number in the queue that were there at the previous minute, plus if there's an arrival at this minute, and then subtract whether or not we have an exit from the previous minute. So again, that's the number that we had in the queue at the previous minute, plus whether there's an arrival in this minute at time t, minus if there was an exit at the previous minute. And then otherwise, what we have is a case where the server is not busy and there's no customer exit. In that case, it implies that there's no arrival because the server is not busy. And in that case, the number in the queue is just going to be simply equal to the number that we had in the queue from the previous minute. So putting that all together into an Excel formula, we'll have some if statements. So we have first check is if the time left is greater than 1. If it is, then as I mentioned, we're going to have the number in queue from the previous minute, plus we're going to determine is there an arrival at this minute, it's D10. Otherwise, what we'll do is we'll check to see is there an exit at time t minus 1. If there is, then what we're going to do, I'm going to actually do the max of 0 to make sure that we don't get negatives here, just as a precaution. And then what we're going to do is have the number in queue we had at the previous minute, plus whether there's an arrival or not in the current minute at time t, and then subtract if there's an exit at the previous minute. And then our otherwise case is simply that it's going to be the same queue as we had in the previous minute, which is E9. And then we close our brackets and complete that formula. Now we have a formula for the number in queue that we can copy down for the remainder of the minutes in our simulation. And then we calculate down. The last step for this simulation model is to generate the metrics for the results. So what we're going to do now is update the formulas in the top right hand corner, which I've highlighted in red. First thing we're going to do is determine is the number of arrivals per hour that we're simulating going to be similar to 10 per hour, so that's a check. And then the last two are metrics about the server utilization that we're getting in our simulation model, and then also the average number in the queue that we're getting for the simulation model. But one thing we should consider here is that what we're modeling is a system that's open 24 hours a day, so like an emergency department, for example. However, we've simulated an empty system at time 0. So in this type of a system, it's actually not appropriate to do our metrics on the entire system. What we really want to understand is the steady state of the system, especially if we want to compare it to an MM1 formula, for example. And for that reason, we should have what's called a warm-up period. And what we'll do is we won't count in this case, the first day of the simulation, and we'll just do our metrics on day 2 all the way to, in this case, day 15. So what we're going to do is simulate 2 weeks of this queuing system. So we're going to just do our results based on days 2 to 15. Okay, to determine the arrivals that we have, we're just going to do a sum formula. We're going to sum all the arrivals that we have, and now I'm just going to specify the cells. I know that day 2 starts actually on cell 1449, so D1449, and I'm going to sum all the way till the last minute in time on day 15, which is in cell 21,608. And of course, you can check this yourself if you'd like to on the rows that we have, to make sure that you get the right number. Now that's going to sum up how many arrivals we had over the 2-week simulated period, which is excluding the first day warm-up period, of course, it's just days 2 to 15. But that is still 14 days. But then what we want to do is to figure out what is the arrival rate per hour. What we're going to do is divide by the number of days and then times the number of hours. And that will give us our average arrival rate that we've simulated. And it looks like we're getting 10.03 per hour, which is very close to our 10 customers per hour. Now for server utilization, what we're going to use is the busy column. So when the server is busy, that will be 1, and when the server is not busy, it's 0. And if we want to get a proportion of the time that the servers utilize, we just need to sum that and divide by the number of minutes that we're simulating. So in this case, we're going to have a very similar formula as the previous one, but it's going to be different. First of all, of course, we're going to have using column F. So we're going to have F 1449 to 21,608. But in this case, we're going to divide by the number of minutes. So we need to divide not only by 14 times 24, which is the number of hours that we've simulated, but also times 60, because we have 60 minutes as well per hour. So if we do that, then we're going to determine how much, what proportion of the time the server is utilized. In this case, we get 85.65% of the time that server is being utilized with this queuing system, with these particular parameters. And then the last thing we're going to do is to get the average number in the queue. And to do this is just an average of our queue, which is column E. We have a column to track the number in queue at each minute at a time, so we can just use the average formula here. And then what we're going to do is just take the average from E, again 1449, to E 21,608. And in this case, we get an average at 3.9. I think we should expect about an average of 4 from a queuing system of this type. Well, there it is. There's our spreadsheet simulation model of a single server queuing system using each row as simulating a minute in time. Hope you enjoyed this video. Thank you so much.